Alright, time for another draftphysics.com, debatephysics.com also, but you can't get anybody to debate anything, okay? Especially physicists. They're all pathetic cowards. So there's a lot of these, physics presenters, let's call them, on the internet, and most of them are, kind of mushy and pop culture-y and friendly. And Thunderfoot's a bit of a outsider in that class in the sense that he does now and then show some integrity and point out how other physicists are talking shit. But he really only does it about the gimmick science. I mean, the stuff that everybody should be able to figure out anyway. I mean, the stuff they make TV commercials out of or some other crap. And, everybody should already know that they're just saying, show me the money. They're just saying, let's see how we can turn this into a opportunity to make money, and they're calling it science. But anyway, so he's been picking on Elon Musk for a couple of years, and it's all so fucking redundant. I mean, you can't. They're almost unwatchable videos because there's almost zero new content in them. He just keeps replaying the same clips and replaying the same statements about, he expects to be paid $270 trillion over and over and over and over. And I personally hate Elon Musk. I hate everything he stands for, the whole capitalist horse shit of racket after racket. They come up with a racket and they make the company public and get a big payoff and then, start something else. And, it's just, I hate venture capitalists. That's all Musk is the worst epitome of. He doesn't, it's not his money. It's always the sucker investor's money. And he gets a big giant payoff for, just creating vaporware. But anyway, that aside, Thunderfoot just annoys the hell out of me. Always has. We just have a personality conflict thing, nothing in common. And we've both been doing this internet thing for, 20 years or whatever. And it started with being an atheist, and Thunderfoot chose the route of, well, let's just find out some kind of crap about their personal life and attack the defenders of the faith by showing some kind of, debauchery in their personal life or some other kind of crap, instead of just making arguments about how God is a bad theory. And, it's pretty tacky, frankly. So I find it offensive. And he's some sort of a philosophical nihilist. I mean, he's one of these people who doesn't think that we could figure out that we personally feel, we feel good and we feel bad, and they're real concepts, good and bad. The feelings speak for themselves, and we have to do this expansive thinking of figuring out that, other animals and other people also have good and bad feelings, and that just as I don't think the universe needs me to be tortured, it doesn't need any of them to be tortured either. It's not a good thing. It would be a bad thing. Torture is bad. Okay. So it's that bad, where you have to explain to philosophers, scientists, that torture sucks. So, anyway, I put his, pretentious, I'm a doctor photo. And look, there's no taking credit away from people. It's hard work becoming a doctorate in physics, so I'm not shitting on that entirely. I'm just the whole idea that it entitles you or that it instantly means, and it doesn't do any of that. It's not an instant sign of credibility. Lots of PhDs have said silly shit. You still have to prove you're qualified to preach. He is very preachy. All right, so I think he does most of the physics he does in his videos pretty good, generally speaking, but none of it is foundational or elemental. So he doesn't pick on any of the really dodgy science, like gravitational waves. You could even go with the lensing, in the space images. I'm sure if he picked at those photos, he could see that They're, a creation of a system of software that's intended to create a universe that we want to see. Not one. And that's, some of these things are just obvious artifacts of that process. Sometimes there's a galaxy here, and in the same image, the same galaxy is over here, and there's no math, there's no anything that makes that possible. But anyway, it's garbage. Anyway, so that's not really the subject, but we can get into the whole subject of photons, get into lots of subjects. So the real point of me making this video is Thunderfoot is a fucking coward, okay? I mean, twice I emailed him, one time offering him $4,000 to engage in a debate on the subject of 1/2 mv squared, and showing some sort of proof that this crappy piece of dogma has something to do with the scientific process. Because again, if you research it, Leibniz had no evidence. He had a statement: 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. Never did the experiment, doesn't have any evidence to show anybody, can't even testify to his personal experience because he didn't have any. He just assumed it was correct. And the funny part was that he actually did trick some Newtonians into thinking that was also correct, and they made excuses like, well, God did it, or some other kind of crap. And it's just kind of funny that, and then 350 years, 400 years later, we still haven't done the experiment. We just say it's true, we don't demonstrate it's true. And then again, if he took any kind of time, he's a bit of a chauvinist, frankly, and so he should really go after that Madame Chartelet, because everything she did was a gimmick and shit. Okay, the experiments weren't thought out. They weren't they weren't going to get the conclusion. They weren't going to get to the right conclusion because they were wrongly premised. Denting clay with round objects is not going to be a good test of linear motion. It's not a linear thing you're dropping. And then you can talk about rolling things, and then you can, it's a gravitational argument, and it's clearly obvious that, yes, something going twice as fast should roll 4 times the distance because it's clearly encountering less friction for a substantial portion of its journey. Just a fact, And, all these things are things that should be debated by physicists. Physicists should answer these questions, and they won't do it. I can't get one of them to show up to even just to play my argument as a video, and where I don't even get to say what about, I don't get any counter punches, and they won't even debunk the cold video. Okay, they won't even take that and take advantage of the fact that I won't be able to talk back. Nothing, from these cowards. So anyway, this is a little clip of Thunderfoot. So he's doing a video basically debunking some asshole, 2-Bit Da Vinci. So one of these pop culture channels that sells a lot of bullshit and hype and hope and all that kind of crap. And so it's good he's doing that, but it's bad, okay, that he doesn't really point out that physics really should tighten up its own, its own, yeah, its own bullshit, okay? The 2-slit experiment, I could go through all of the misrepresentations. I mean, if he was going to do this debunking thing, he should debunk Feynman talking on this subject, because everything he says is just bullshit. I mean, he has so little connection to the actual experiment and what it actually produces as a pattern. So they just won't come anywhere near these subjects, and they should just be outed and busted as the duplicitous hypocrites that they are. Okay, so they will debunk the science they don't like. Okay, but their own religion, now you can't touch it. It's sacred. Don't be poking at that. So yeah, let's play some of this horse shit. Anyway, so this is going to be on the photoelectric effect, and he's pointing out that Einstein didn't discover the photoelectric effect, and I think that's known. I mean, I've pointed that out. And his explanation, though, is 4 paragraphs. It's not a very deep explanation, so you can't get much out of it except him saying almost what Thunderfoot illustrates here, which doesn't really explain why there's a distinction, and it doesn't really account for things they already knew about light, which was that it has polarization, and that its polarization is about 1,000,000,000 times bigger than an electron. And so the whole idea of a photon, actually one photon hitting an electron, is very unrealistic. In any sense, that where the photon is, how can it do that when it's 1,000 atoms across? How can it hit one electron when the photon, to be to have its character, its polarization, it's got to be very large by comparison, whatever the composite is. Now I'm arguing the little bits are very small, the little energy quanta that Einstein talked about, they're very small. But the fact is, a photon isn't one object. It's a pattern. It's a frequency, for fuck's sake, people. It's a frequency. You have to account for the frequency. How do you make a frequency out of, beach balls? Except to make very small beach balls at a distance. Okay, you can't just make one beach ball and say, there's 500 megahertz. No, it ain't gonna work. Anyway, so I'll play this little clip and just point out how, it's so simplistic and silly.
Or explaining the photoelectric effect. The basic thing was, if I shine an equal amount of energy of red light and blue light on a metal, only the blue light kicks electrons off the metal. But what?
So, and the key to this is there's 2 photoelectric effects. There's photoelectricity, okay, where you create electricity in the metal, and then there's this photoelectric effect where you launch electrons off the surface. So there's really 2 effects, and they're, red light will make photoelectricity. So, it should be understood that there's a distinction between the 2. There's not some cutoff. There's one of them does part of the job, and the other one does a more complete job of removing an electron. So we know both of them disturb electrons, and clearly both of them disturb them in a way that is something very familiar is being created, which is electricity.
Fine, I put the same amount of energy into both of them. Why didn't I evaporate the same number of electrons off both of them? Einstein basically put together the idea of photons interacting with electrons, and the red photons don't have enough energy to kick.
Right, and the word energy, don't have enough energy in what way? So this is the part that they just leave kind of vague, like, well, you're bouncing them off a surface or something. So they think of it actually like you're just hitting them and saying, how much can they bounce after I hit them? And I think they could know it can't be that crude. In terms of an explanation. Now, earlier in this video, Thunderfoot's talking about water drops and how adhesive they are, molecularly, and how hard it is, in some respects, to evaporate water off a surface. And that's why you have to make it hot for you to do it. You have to really jiggle the hell out of them. And so he's already understands this idea of electrons being connected to each other through all of these molecules and all the hydrogen atoms, and those would be the electrons and the hydrogen atoms are the things that are creating the opportunity, all right, for this association between. He even uses the term he uses magnets as an example, pulling magnets off of a pile of magnets, little magnets. So it's so similar to what I've argued. In the sense that it's all connected, and you really got to you're pulling off of something that's connected to other things. And once you realize that it's connected to other things, then you can understand this photoelectric effect has something to do with something a little more complicated than just throwing, as Al-Kahari did, ping pong balls and golf balls. Blue light isn't golf balls. It's a tighter frequency, so you can understand it's implying the energy in a shorter amount of time, the same number of units of frequency. So let's say there was 3 units of frequency, 3 cycles. And let's just say 3 cycles was a photon. Well, 3 cycles of red light happens over this much time. 3 cycles of blue light happens over this much time. And that's the big difference. And so now, the obvious, the conclusion that came to me pretty quickly was this is a tipping point argument, that you're tipping something. And you can't tip something if you allow something to move and then slow down and then hit it again. You can't increase its velocity. But if you have something moving the speed of light and you hit it once and it gains some velocity, and then you hit it again before it slows down, then you're doubling its velocity, and then you could quadruple its velocity. And so this whole effect is really just based on that mechanism. And the red light does the tipping. It does push, and so it creates electricity. It gets electrons moving in a direction. All right. And the blue light, though, hits them so hard that the electron has enough energy to escape its nucleus. And that's the difference between the two, is just the fact that you've produced the energy in a shorter amount of time. You're imposing it in a shorter amount of time. That's what doubling the frequency means. Less time. The period is half the period. It's half the time. Delivering the same golf balls in half the amount of time will likely do a lot more work on a surface than giving the surface time to absorb and relax. So it's like pushing a kid on a swing or anything else. You could even understand it that way, that even if it was oscillating, you can only add energy if you put the energy in the same direction when the object's moving in the same direction. If you try to put the energy in when it's moving in the opposite direction, you're not going to get anywhere.
The metal. So it doesn't matter how many of the red photons you shine at the metal, you're not going to get any electrons off. But with the blue light, even though you've got half the number of photons, their energy per photon is double. So even though you're putting the same amount of energy onto the surface, only the blue photons have enough energy to kick an electron.
So the balls themselves, the light is moving the speed of light. So you can't really double the energy of the composite energy quanta, as Einstein put it. You can't make more energy quanta, all right, or less. You're just saying, look, if I can compress the energy quanta into a smaller and smaller amount of space, then when it hits the surface, it'll be the difference between the recoil of the gun and the bullet. The bullet doesn't have more energy. The bullet is just going to deliver its energy in a much shorter amount of time. And that's a huge advantage because most surfaces can't spread energy. They can only spread at a certain speed. So Thunderfoot in this video does actually mention how it's the speed of sound, okay, that pressure moves through water. That's a common thread in all of this stuff, that materials are dependent on the speed of sound in those materials. So we know that sound and those movements, or movements of the atoms, has an awful lot to do with how it absorbs energy. And if you put energy in faster than the speed of sound, then obviously that thing can't deal with that energy in the sense that it's going to break down. It's more likely to.
Off the metal. The whole thing was a fundamental understanding about the interaction of photons with electrons.
So it's not fundamental, it's not elemental, it's a really bad animation, it really doesn't say anything, doesn't explain anything. And again, if the polarization of the light is many atoms across, so this part I'll draw, just to point out, I think a more practical explanation of why it happens. I think I can provide that, a better explanation of how the electricity first is created and then why you eject electrons. So the idea would be, as a photon traveling through space would be something like this. This is the frequency. So let's just say it only takes 3 energy quanta. Okay, so if 3 quanta hit, you got a potential photon. And obviously red light would look that way and blue light would look this way. Okay, so obviously it's going to hit with a much shorter period of time. So suppose that one of those bits hits an electron. Okay, so let's just say the polarization is, these things are all flying parallel, but the point is they're at different locations, almost like an antenna. When you shoot the electricity up the antenna, you're going to be releasing the quanta, the photon quanta, at different positions at the speed of light. So it's going to come out, the first bit, and then the second bit's going to be displaced from that, but all those lines will be parallel. So the photon is moving parallel this way, the bits, okay, with a timed difference between, okay, where they are. So this is the frequency, and the polarization is the fact that they're a little bit they're not traveling right behind each other. So let's say you had a material surface and there was an electron, and you hit this electron with one of these bits. And the idea would be is that electron will push into the atom, and guess what will happen? The atom's going to get misshapen because this electron will push on the other electrons around the nucleus, and it's going to probably push them out this way. So the atom essentially gets fatter, right? And so it can get fatter in all kinds of directions, but the point is it's getting fatter because it pushed electrons out. And the idea would be is now this next bit, the first bit hits, and then the second bit, in one of these directions of polarization, it'll just happen to hit another electron. And when it does that, the force from this first hit is still moving in these electrons. So they're still moving at some speed, okay? And now you've hit another electron behind it, which means it's going to get pushed a little bit more. And so you're adding velocity to the electron. And by the time the third one has to hit on this order, and that's when you have a photon. So you hit it twice, 3 times, and it's in sequence, and that decides the polarization of the photon. So most of the photons won't be registered as photons. Okay, they'll be invisible. They won't register as a visible photon because they can't fit the pattern. All right, so there's always more photons going with photons than the photons you actually end up seeing, would be the argument. And the same effect can happen when you use polarizing films, and you block all the photons, and you stick another one in, and you get some of your photons back. The point is that the photons weren't dead. There wasn't no energy coming out of the plastic film. It's semi-transparent. It wasn't blocking the photons. It's disrupting the photons, so they're not effective as photons anymore. But all the little bits, all the little light quanta is still hitting the surface. It's just now hitting it incoherently, so it can't push electrons like it could before. So it's a composite thing, and it's an event on a surface. A photon isn't bang, photon. A photon is an arrival, a sequence of events, okay? And that's what the photoelectric effect demonstrates, is that the blue light can keep pushing, adding energy. The red light can't add energy because it's not hitting soon enough while the electrons are still pushing pressure. It's too far behind the pressure of the electrons moving. So it can't add velocity to the eventual electron that leaves because it just hits too far behind it. All right, let's see what else. No, I'll just play the end of this. That's what I'll do. And just say, well, this isn't exactly the subject I wish to talk to Thunderfoot about, or I wish to argue with him. But I'm just pointing out that these subjects need to be talked about, and the physicists just don't talk about it. They just take their old dogma, something that was said in 1932, and they just keep repeating it. And so they find little catchphrases and turn them into 10 commandments, and they will not veer from that dogma, that archaic often dogma. And such. So I'll leave us there.
Thing is, we now actually know a heck of a lot about the interactions of photons with matter.
So I don't think you know a heck of a lot. See, I mean, Einstein died saying, I've been studying it for 50 years and I haven't improved my understanding one iota. So, there's a lot of, I don't think, any understanding, because I still don't think you understand what force is and matter is, okay? And they're two different things. And force is collected by matter, and it's a real thing. It's not a liquid, but I mean, you might as well think of it that way. And electrons, every time an electron moves in the universe, it's pushing force um, constantly. It doesn't have any energy of its own. It's only a conduit that allows force to interact with force, because force can't hit force. Force can hit matter. And when it does, it allows it to push into other force. So all of that is, I think, an incredibly important and interesting subject, but you won't listen to any of it. Because you just say, I don't have a PhD, therefore I'm not worth it. Okay, so let's go to the he has a little ending here where he talks about how people need to do good science, blah, 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 and he doesn't do any of that. So there's his little douchebag picture. Yeah, see, you have to be a doctorate in physics or you can't do physics. Because they don't understand it as a concept. They understand it as math and axioms they never proved.
Thunderf00t. I'm a scientist who makes videos on YouTube debunking popular, scientifically literate bullshit for some 18 years now.
Right, and it's all kind of, again, redundant, and you're just picking on, it's it's rotten fruit. I mean, frankly, PhDs shouldn't have to be doing the picking on some of it, because it is such a racket. And the fact that there's just so few people who have any interest in doing any of this fact-checking.
And a very big thanks to all those who have supported this channel through Patreon throughout those years.
Right, so you've been very fortunate in the sense that, years ago he wasn't getting anywhere near 314 views, 3,000 views per video. Now, he could argue that he's now resentful that he's not getting 1 million, but whatever.
If you want to join their ranks, links below. But the sad reality is that it's a lot easier to get attention for bullshit vaporware claims than it is to show that they're bullshit.
Right, so and it's not about attention from the public. It should be attention from a community of humans that are scientifically literate. And it's when they're the salesman, that's the part that's scary. They're going, what's in it for me too? The scientists are just as sell out and full of shit as they could be. This whole gravitational wave thing. We know the only reason why that piece of garbage was built is because of its military applications. And that's it. But did they even peep those words of that, we could have used this as a big listening ear, and that's why we built it? Because we promised something that they can't deliver anyway, in the sense that they can't even show us how well this thing hears, because they don't want to even imply the second use that it has, eavesdropping.
I mean, to sum it up in one word: hyperbole.
So you keep going on and on about that one. So that's already failed dismally. I don't think it's a going concern anymore. So it's sort of old news, but whatever.
It's not getting any better. The quick version would be, they're all bullshit.
Hey, I'm Ricky, and this is 2-Bit Da Vinci. I'm an engineer who spent the last 10 years working on fighter jets and another 10 years in software, but now...
What does that even mean, working on fighter jets? What did you do, clean the windshields? It's just, come on. I worked on fighter jets. I did detail a Maserati once, so I can say, should I just say, I detailed Maseratis.
I'm a YouTuber building a community of curious people. Join me as I find the signal through the noise and break down the complex stories shaping our world with fun facts.
I don't know exactly why he's playing so much of this, but whatever.
And context, and bring you an engineer's guide to the galaxy.
Seriously, show me one thing on Matt Farrell or 2-Bit's channel that has even slightly delivered on what it promised, or on the hype video.
Yeah, well, I mean, none of these science channels are anything but redundant regurgitation of, the standard crap. and they all end up buying the little kits to do experiments with, even Veritasium resorted to buying a $10,000, double slit experiment kit, that has a nice, interesting electronic filter that basically makes the thing do what you need it to do, because it basically just eliminates all the results that aren't consistent with the outcome you're trying to propagandize. I mean, it's hilarious. Why would it come with something deliberately designed to filter out photons?
Fight for scientific literacy, because without it, and without the ability to distinguish well-presented bullshit from cold, hard facts.
Okay, so yeah, let's go again. It's such an obvious subject. You have an energy, wave particle is already okay. Everybody with any kind of science literacy should be saying, "Oh, please, we know it's not both, so let's find out what it really is." And you have an energy duality that nobody even mentions. They don't even talk about the fact that they actually have two kinds of energy, momentum, mv, and mv squared. And somehow both of these quantities are supposed to be conservable, and it all works out just fine having two completely different numerical definitions of what the energy of something is, a fuel or anything else. It's just silly. And in 350 years, you can't fix it. And unfortunately, for 150 years, nobody could even figure out that, denting clay with round things ain't going to work as an experiment to tell you how much energy something has. And rolling things in friction probably isn't going to work either, because almost any imbecile can figure out, the amount of friction depends on what kind of surface I roll something on. And obviously, how much gravity is going to affect it. So you don't even understand what gravity is. So it's, this whole bent geodesic bullshit. But anyway, can't have any of these conversations. Physicists won't allow there to be a conversation about their essential axioms. Dark matter, dark energy, all of this hypey bullshit that's totally unnecessary and is crap. All right, so that's probably enough. Yeah, I believe so. Okay, yeah, I'll leave it there. So, yeah, fuck you, Thunderfoot. I mean, you're just as bad as the rest of them in hypocrisy and duplicity. You're just as unreachable. You're just as impervious to accepting an argument and countering it. Yeah. So, yeah. Fuck you.